Good morning. Looks like we're live. I'm just gonna tweet real quick while I wait for the YouTube live stream to catch up, because it always takes me a little bit. The third day of the practical model evaluation workshop. Today we evaluate, which is what we're doing today. We are evaluating our models that we trained yesterday on a number of different axes and considering a bunch of metrics and then picking the model that we want to use. So that is the point of today. Excellent. It looks like YouTube has caught up to me. Hello, everyone. We will... so the plan for today, just like the previous day, is I'm just going to sort of like talk at you for 30 minutes, and then I will go to the chat and answer as many questions as I can. And I haven't been able to get to everyone's questions every time, and I'm sorry about that, but I'll do my best. Gotta hydrate. Okay, so the notebook for today is linked underneath the YouTube video. It is also the same URL as the past 2 days, except it says -3 instead of -1, and I think I should have finished, this one should have finished running. So you should be able to go back and see, yep, the links for each of the days by looking at any of the notebooks. Yesterday, just to refresh your memory, we trained 4 different models. So we trained just a baseline model that's XGBoost that has had no hyperparameter tuning. We're just using the default hyperparameters. And then we started a model training using CloudAutoML. And that is this model right here. So it is finished training. And I did kick off a second model training this morning before the stream. And I'll talk about why a little bit later. So hopefully the next time I look at the screen, there will be 2 models there. That's ideal. And then we also trained a model using Teapot, which is an AutoML library, and one of the things that it gives you that I think is particularly nice is all of the pipeline code that you can download as a .py file. And then H2OAI's AutoML is the 4th model that we trained, and today we're going to be evaluating all of them. So at the end of yesterday, we saved out all of our different models. So we saved out the XGBoost baseline model. We saved out, this is the H2OAI model output. We saved out the Teapot pipeline. And then I saved out the training data, but I completely forgot to save out the testing data. So I did rerun this notebook, and now it has the testing data too. I don't know what I was thinking. I think I was just, stuff slipped my mind. Also, yesterday somebody asked about BQML, and I was like, oh, I haven't used that. I definitely had. I did a whole workshop on it. No, the biggest difference between BQML and AutoML is that AutoML does automated hyperparameter tuning, and BQML does not. It is a library for doing machine learning in SQL. I don't know why that was not something that I remembered. It's fairly early for me, so that's my excuse. So those are the things that we did. I've also changed something else in this notebook because of problems that I was running into that I will talk about today. But I added this line here, this cell here, let our model know that input columns may have missing values. So I was running into a problem yesterday when I was trying to do inference where NA was being treated as a category by the model during training, but at inference time that was being treated as a missing value, and because I had not explicitly mentioned that my columns might have missing values, I was getting errors out. So I added this little section here, and that is why I have retrained my model, and this one, oh good, it is done running, so I should have retrained versions of all of my models that we trained yesterday. And I can add those to my notebook for today. All right. Do you wanna let me edit it? I've had this tab open for a while. I might have just had my session timeout. So today we're going to work on different types of ways of evaluating models. And on day one, we talked quite a bit about the different things you might want to consider. So you probably want to consider performance on whatever your loss metric is or whatever relevant metric you're using for your models. But there's also other things. So some of the other things that we're going to be considering today, all of the other things that we're going to be considering today are how long did the model take to train? How long does it take to actually do inference? And here we're going to be doing batch inference. So if you're not familiar with the difference between batch and streaming, streaming is where you send one request at a time and you get back one piece of data at a time. Batch is where you send a big data file and it's got a lot of different things in it, and then whatever it is that you're doing is done over all those things and you get the results back. So that's the difference between batch and streaming. And we're doing batch here rather than streaming. We might get different results back for streaming. The overall accuracy of the models, and I'm using sort of a very easy to interpret measure of accuracy here, and that is accuracy. So just how many of the job titles in the testing file did you guess correctly using your model, which is maybe not quite as informative as something like log loss. But if you're trying to communicate your model efficacy to someone, I think accuracy tends to be a little bit easier for people to sort of wrap their heads around. So that's why we're using that. And then looking at error analysis, we're going to look at error rates across different classes in our multi-class classification problem. And then finally, and this is one that is going to be an exercise for y'all to do, and I might do today if we have time, we'll be looking at how performance changes if we change one variable that one of our stakeholders maybe told us should be particularly important for a specific class. So, and this is the counterfactuals that I mentioned on day one. All right, so some boilerplate before we get going. So I've got my imports. I don't think I actually set a seed. What did I set it to on day two? I think I set it to either 100 or 42. 42 is what I set it to, so I'll do that. 42 is a joke from a book. It's a Douglas Adams book. Oh no, I got errors. What's my errors? Tell me my errors. Field model display name. The display name provided is longer than 32. All right, so we may have to, so I think the problem there is that this name here, Rachel AutoML example model nullable, the name itself is more than 32 characters, and so it couldn't train the model. So we may do something a little bit different because I do have a trained model that I used for the other notebook. So be warned, don't have a model name longer than 32 characters. We'll get back to that. And then my data source for this notebook is actually the notebook from day 2, where we saved out the training data, the testing data, and all of the different models, and I'll just use those models today. So you can see all of the files that we have here, the XGBoost model, the training and testing data, the teapot pipeline, and then the output model from, the winning model from the AutoML, H2O AutoML, run, I guess. And because we're going to be working with models that do require encoding, so Teapot and XGBoost both require that you have numeric inputs. They won't accept strings as inputs. We need to make sure that all of our inputs are numeric. So that's what this whole section is. So we're going to run this cell just so it kicks off. And then we're going to load in our models. So each of the models that we trained yesterday needs to be loaded in a slightly different way. So XGBoost, you can do load a model that you saved using save_model, which we did, using load_model, and this points to the file that we saved out. And here I am using the I'm setting the LE parameter, which stands for label encoder. So remember that we have our our data from the so the model itself is trained using numeric data because we've used encoded data. And in order to get the text labels back out, we need to have the information of which labels go to which text. And by using by fitting the label encoder to the same column of the same file that it was originally trained with, we should get the same labels back out. There's an outside possibility that I've done this bad because the performance of XGBoost is surprisingly bad, so we might rerun that. So that's loading in the XGBoost model. For H2O, first we need to initialize, well, actually I can just run this while I'm talking about it. First we need to initialize a server running locally, so this is just sort of in our notebook. And then we need to load in our model, so this is the one that I saved, and this is a gradient boosting model. And then I'm going to, because we want to test our data today, I'm going to load our testing data into an H2O frame, which is like a data frame, but it's not pandas. It's a different version. It has differences. So eloquent. And then this last section is the code portion from the teapot pipeline.py. So we're just retraining a model using the winning pipeline. And I modified this a little bit. So for example, it doesn't, it'll take in these X encoded dot values and Y encoded dot values from the encoding that we did up here. So this is training all of our models. And then we have a problem, server error. Illegal argument. So I think I have actually pointed this to a file that doesn't exist. So let's really quickly see what the file is called and see if that will run. I think there might have been a typo in the file name. So the cluster is running correctly. Okay, and now it's parsing correctly. Excellent. Yeah, I think that was just a typo in the file name, so that should be fixed. And then we're going to train our gradient boosting model. And then we have this setup for GCP. So we won't actually read our model into our notebook. All of the GCP CloudAutoML stuff is being done on the GCP servers on their hardware. And we're just creating a connection that we can use to send information back and forth. Aaron brought up to me that it's not exactly apples to apples because all of the other models are being run on the kernel hardware on the same hardware, and the CloudAutoML models are being run on the hardware that's backing AutoML. So a good thing to keep in mind. And I'm actually not going to change any of these because I have attached the same, this should work, because I've attached the same account that I used to train this model. So if you don't have my GCP account, which you don't, you're going to need to update these with the information from your model. So Kaggle AutoML example is the project that this is from. You can see that I actually have two models here, so I'm going to delete one of them. Which one was most recent? This one was most recent, so I'm going to delete this guy. Beep-oo, goodbye. If you try to run classification when you have two models that have the same name, you will run into trouble. So this should allow us to use this model, which I created in the original notebook, and just continue with no changes. Where are all of these pieces of information coming from? Kaggle AutoML example is my project name. Kaggle AutoML example. The data set display name is the data that we've uploaded here, data jobs info 2018. We talked about uploading that yesterday. The target column job title comes from this data set, and it'll be the column in the CSV you want to predict. So here you can see job title I've set as the target previously, and it's spelled the same. And then the model display name, Kaggle AutoML example model, is from the name of the trained model, and this is one that I set in my notebook, Kaggle AutoML example model. So you would want to get all those pieces of information from your account for your particular project. Oh, and just something to note when you look at this data set and you look at I want to scroll over. Well, I'm just going to zoom out. You look in the nullability column, you can see that these are all nullable. So this is the change, except for the target column. So this is the change that I made so that the model will do inference if I have columns with missing rows. So that's the big change between yesterday and today. So again, I'm not actually doing anything with the model. I'm just, actually I can get rid of this because I don't care about training budget right now. So I'm not actually doing anything with the model. I'm just creating these little client helpers that will send information to GCP and get information back from GCP. All right, so now that everything's all set up, which can take a while, we're going to talk about comparing time. So training retraining time. This is a markdown table, which is not great to look at with our eyes, so I will stop clicking in there. The fastest model was definitely XGBoost. This makes sense. So I retrained the model and used the time it magic. If you're not familiar, you would put this as the first row in a cell, and then it will run the cell several times and give you an idea of how long that code takes to run. So the mean run time and also the standard deviation. So you have a good understanding of how long it'll take to run a model like this. And for XGBoost, it takes about 10-ish seconds. That makes sense because XGBoost is a single model and we're not doing any hyperparameter tuning, whereas all of the other models that we're looking at not only are trying multiple classes of models, but are trying different hyperparameters for each class. So it's not surprising that XGBoost is fastest. Teapot took I gotta stop clicking. Teapot, this one, took the second least amount of time, so about 10 to 15 minutes. H2O took up to an hour, and Erin said she was going to run some additional benchmarking, so if she's in the chat, she can share that. But less than an hour, and then CloudAutoML did take exactly an hour, because that's how we said how long to run it for, and that's also the minimum amount of time you can run it for. So it will always take at least an hour to train a CloudAutoML model. So if I need to retrain a model, which for a AutoML model you probably are going to have to retrain, that's how long it would take me to retrain each of these models, and the fastest was XGBoost and the slowest was CloudAutoML. Inference time. Okay, how long is it going to take us to actually get information back from our models? So I've used the time magic here, which tells you how long it takes to run the code in a cell. So here, the Teapot predictions took about 77 milliseconds. The XGBoost predictions took about 117 milliseconds, and this will vary a little bit from run to run. The H2O predictions took 1.04 seconds. And then we get to CloudAutoML, and there's some additional steps that we need. So the first thing we need to do is a way to, so again, this is not being run locally, so I can't just be like, hey, look at this file over here and use that, or look at this object in my Python namespace, I guess. And use that one. I have to send the data somewhere, and then it generates the predictions in that somewhere. Specifically, it's going to be in my bucket, and then I can go and get that information back. So I've taken this function download to Kaggle that I don't think I actually use. So I'm just going to delete it. But if you wanted to use it, you'd be welcome to. And this one was written by Dev in his Titanic AutoML example kernel. So if you haven't seen that, that might be a good thing to check out. His username is DEVRRET, I think. I might be wrong about the second vowel in there. So I need to pass it some information. So the information it needs is the name of the bucket. So if I go to my what is this called here? My project homepage, and I click on bucket. This is the bucket that I created when I started my project. When I uploaded my data to create an AutoML data set. So we created this bucket yesterday, but you didn't see it because this isn't the same project as it was. But I created this using the same process. And if I click in here, you can see I have some files, and I also have this folder called predictions. And I'm actually going to create a new folder, and I'm going to call it predictions live. All right. I hope it doesn't hate underscores. So I've created a new folder, and there is nothing in this folder. And the reason I'm doing this is to show you what you need to change if you're going to be doing a new folder. So this I don't need to change. I've also uploaded the test data. So this test data file into my bucket already. So if you look at my bucket here in the top level, you can see this file test_data. Sorry, that's very small. Let me make it bigger. Test_data_2018. And if I look at this URL, this part means that I'm pointing to somewhere in cloud storage. So Google storage, I guess. I don't know. So that I just leave, and then this would be the name of my bucket, and then this is the file. So I've uploaded that already. And then for the output, what folder do I want to put my outputs into? So in the example, I had it in predictions, but I actually want to put them in my new folder that I've made, predictions live. All right. And then this is the this is the command that will actually do our batch predictions. So I'm going to be using the model display name that I've specified up here in my setup bin cell is the word. In my setup cell, Kaggle AutoML example model. Scroll. So it's going to reach up to get there. And then I'm going to get the input using the universal resource indicator, I think is probably what the I is, that I've specified here. And then I'm going to put my output into this, this folder that I'm specifying here. So let's run that. And that takes about 1.52 seconds. So it is the slowest of all of the ones that we're looking at, but it's also the only one that's not running locally. So that's not super duper surprising. And now we want to download our results. So if we go back to here and we look in predictions live, where's my results? Show me my results. All right, so it might take a little bit to, let's see. Done. Are you done? Oh, no, it's still predicting. So this is the time it took us to kick off the predictions, but it's still actually doing the inference. So we'll come back to that in a bit. And then this will need to be changed to point to the file where my results are stored. So Kaggle AutoML example, I'm going to need to change this to my new folder, predictions live, and then this will be the folder where my where both the predictions and any errors you have will be stored, and then tables_1.csv is going to be where you have your non-error row predictions. So simple. And I should say this product isn't really designed for this sort of like working from a Jupyter workflow. It's more designed for again, doing more enterprisey things. So probably the most common way of using this is once you have your model set up. Show me the model. Once I have my model set up, I can do online prediction once I've deployed my model, and I can also use an API for my model again once I've deployed my model, which we're not going to do because it's just another step. So this is designed to sort of like fit seamlessly into a REST API workflow, and not so much to be used back and forth with a Jupyter notebook. All right, so And have we gotten our predictions yet? Are you done? Not yet. Okay, we'll come back to that. Or actually, so right now this is pointing at a prediction file that does exist, so I'm just gonna use the one that exists. Pretend that we just finished that one. Here's one I made earlier. So I'm reading that in, I'm downloading the blob to a file, I'm saving it in my current working directory, and then I am reading it in as a CSV. And if we look at our cloudpredictions.df.head, show me the top of the file, you can see that we have our input variables, and then down at the end we see the probability assigned to each class by the model. So that's the prediction part. All right, now that we've done the prediction and have information about how long it takes to do prediction for each of these models, let's compare some metrics. So the teapot predictions are in this data frame. I'm going to take the data frame, which at this point, if we look at just teapot, well, let me run this. If we look at just teapot predictions df, you will see teapot.head. There we go. You will see that these are numbers and not words, and the actual classes that we have are words and not numbers. So in order to convert those words back to numbers, I'm going to inverse transform the data using the encoder that we've trained earlier. So any encoder, most encoders, should have a way for you to take that encoder and take data input and switch it around so you get back to the original data. The H2O predictions, I am saving the predictions I made earlier as a data frame. And then XGBoost, we just have the predictions out, so I'm just using those. And then for CloudAutoML, because what I have right now is actually the percentage or the proportion probability distribution across each of the classes, I am taking the column, so I'm filtering the data frame to look at just the columns that start with job title underscore, and then I am creating a new column that has the column title that was the maximum in that range for each of those, and then I'm removing the parts of the title that are not the class name, and then I'm using that to create our list of titles to compare to the actual list of titles. So looking at the accuracy, teapot is at about 49%, so it's guessing correctly about half the time, which is much better than chance. H2O is 0.498. CloudAutoML is 0.531. There were some rows that weren't returned during inference, and I don't know why and can't figure it out. And if any of you know, please let me know. I spent a long time banging my head against that yesterday. Fortunately, we do have in the return data frame the actual labels, so we can use that to compare. And then XGBoost is suspiciously low, which makes me wonder if I maybe actually messed up the encoding. So if we have time at the end, I might come back and retrain an XGBoost model just real quick, to see how it does. All right. Error analysis. So something that is very helpful to be able to communicate about your model is where it does well and where it does poorly. Most models that are working across multiple classes aren't going to do as well in every class, particularly if those classes are imbalanced. And this is something that it's helpful to communicate to your stakeholders to help them build trust in your model and understand where they should/shouldn't be using it. So I have a plot confusion matrix function here that I have modified from the one in the scikit-learn documentation, and this is under BSD license, which is Berkeley something. It's a pretty permissive license. So if you use this this function, you should just add that little bit of comment there. So you don't need to know everything that's in there. It's going to plot a confusion matrix, and then I'm plotting confusion matrices for each of our different models: XGBoost, teapot, H2O, and then the CloudAutoML. So this will give us 4 plots, and I did try very hard to have them tiled nicely, but I cannot figure out how to do it with matplotlib and also this function. So if any of you are matplotlib gurus, please feel free to hop in here. Not my forte. And because it's a little bit hard to see, I'm actually going to pop over to the compiled notebook. Except that is not it. The compiled notebook. There we go. Scroll down to my confusion matrices because I think they're a little bit easier to see in the compiled notebook. That's the only reason. All right, so first off, XGBoost seems to be doing pretty badly, which again makes me think that there might be something up here with my label encoding. So the true labels are over here on the y-axis, and the predicted labels are here on the x-axis. And you want the you want things on the middle diagonal to be high and things off the middle diagonal to be low. So here, for example, if the true label is software engineer, we also want the predicted label to be software engineer. If the true label is research scientist, we also want the predicted label to be research scientist. So a good confusion matrix is going to look like very dark across the diagonal and very light not on the diagonal. And again, this is low for XGBoost, so I might rerun models. For Teapot, this looks much better. There are some classes that seem to be identified much more accurately than other classes. So the data scientist role is correctly identified 55% of the time. The software engineer role is correctly identified 55% of the time. The research scientist role is correctly identified 56% of the time. And then there's some areas with pretty big confusion. So it looks like business analyst and consultant seem to be confused with each other quite a bit by this model. Data engineers are often confused with software engineers, which I think is not super surprising. This is actually sort of nice because it shows us that this model is saying that similar roles are likely to be closer to each other. Manager and consultant tends to be confused quite a bit, which again, I don't think, I mean, obviously we would love for our models to be as correct as possible, but I think it's also helpful to see that it is making mistakes in sort of a reasonable way given our knowledge of the problem. H2O, again, very good at the data scientist, research scientist, and software engineer. Research assistant also seems to be doing pretty well. It's sometimes confused with research scientist, which I think is not surprising. They're very similar roles. So that, again, sort of nice to see that these similar roles are being confused with each other. Again, the business analyst, data analyst confusion is here. And the data engineer, software engineer is even pattern is even stronger than it is with the Teapot model. And then finally, CloudAutoML. Very good at data engineer. If you want to identify what role should be called data engineer, this is your model. But also some other similar confusions that we've seen. Research assistant, research scientist, consultant, business analyst, data analyst seems to be sort of a fuzzy area. Consultants in particular seem to be pretty evenly distributed across different job titles, and that does seem to be pretty similar across all of the models except for the XGBoost one, which again, something might be up there. So, for example, if you really care about getting data engineers correct, the CloudAutoML model might be the best choice for you. If you are really looking for, if you don't really care about consultants, that's probably good. All of these models are going to be a little bit trickable there. So, just something that I think is very nice for communicating models. Actually, if we look at our, do you exist yet? Yay! Okay, so here are our predictions that we have finally gotten out. All right, AutoML tables. So if we look at our model in AutoML tables, you'll see that they have actually created a confusion matrix for you. And the confusion matrix for the model is based on the training data through cross-validation. Scroll. There we go. So you can see, again, this model seems to be pretty good at, actually actually, interestingly, here it says that data engineering is a class that it's not super good at, and that the class it's best at is data scientist. So this is all in fold, and we're looking at out of fold. So that's sort of interesting. Might have something to do with the cross-validation split between the two models. Software engineer tends to be identified pretty well. So this is the same information presented in a slightly different way, not looking at our testing data, but looking at the training data through cross-validation. And we had like a couple thousand rows, 10,000 rows, 15-ish. I should actually probably say in data sets, almost 14,000 rows. So a fairly reasonable size to do cross-validation on. All right. So that's confusion matrices. And then the final part of this is counterfactual. So if things were different from the way that they are, how would your model handle them? So here I have a little example where you have I went out of focus there. A little example where one of my stakeholders maybe has a background as a researcher, and they were looking at my training data, and they're like, hey, we asked this question, do you do research that advances the state of machine learning to figure out if somebody was a researcher or not? I want to make sure that if somebody says yes to this, they're being identified as a researcher regardless of their other skills, because researchers have a bunch of different skills. And if it doesn't do that, I think maybe your model isn't capturing the underlying information in the data set. So to reassure this person, we are, and by we I mean you, going to follow some of the steps that we've done up here, but with a data set that we've modified. So in this modified data set, using the testing data object that we read in earlier, we're going to change the do research that advances the state of the art of machine learning column for every row to be do research that advances the state of the art of machine learning. And I think right now there's only about 600 in the data set that say that, so this will be a significant increase. And then, using each of the models that you are using for this, run prediction on that new data set. And then we're going to plot a confusion matrix. And the confusion matrix here is not going to be between the ground truth and the prediction, but between the predicted values that we predicted with the correct information with that column and the predicted values we predicted with the counterfactual information, to show how the model's classification changes rather than how well the model will do in this fictitious world where everybody does research. And then finally, just spending some time to look at your results, think about them, and just show what this suggests about each model. And then the final exercise, if you were a data scientist working on this problem at a company, which model would you pick to put into production? Question mark. And there's no right or wrong answer here, just some things to consider. The things we talked about today: how long does it take to train? How long does it take to do batch inference? What's the overall accuracy? How well do they perform across cases? Maybe you can imagine that this researcher on your team really cares about researchers and being able to serve that population well. So maybe a model that does well on researchers, even if it does less well for like data engineers, is going to be the better model for you. How does your performance change if we change one of our input features? So again, this is something that would be probably convincing to this fictitious person who just really cares about researchers. And then, is there anything else you might want to consider? Some things might be tech stack. So somebody mentioned Weka yesterday. The reason we're not using Weka here is it has some dependencies that I cannot get to work well in kernels. So if you are using a product and it requires something that no one on your team has ever used before and it's not well integrated into your tech stack, and you're not going to be able to find a good peer reviewer for your code, maybe that's something to consider. Maybe that's something that would push you towards one problem or away from another problem. Cost. How much is it going to cost to serve and run this model? Something you might want to consider. And feel free to share your comments, not this notebook, but this notebook, to share some of your thoughts and comments. And again, I don't think there's a right answer. I don't think there's one model that you should use every time, or like one AutoML framework that you should always use. I think which one is going to work best for you is going to depend on you and your particular circumstances and your stakeholders. All right, let's take questions, because I've gone a little bit over. Let me take a sip of water first. All right. Starting from the bottom. Can I work without Google Cloud? Yeah, just take out the ones that are related to CloudAutoML. So just use the H2AI, the Teapot, and the XGBoost models. Sir Woody Haxwell said, only the Google Cloud platform is remote. The other three run locally. Yep. So there are some differences between how these different models are being run. Who makes, I like researchers who make machine learning libraries. Yeah, I think we all have a big debt of gratitude to especially open source developers like Wes McKinney for Pandas, Guido for, the language of Python, and all of the many people who work on all of the tools we use every day. I love open source developers. I really like the R community. I think I mentioned before, for tabular data manipulation, I prefer R. So I'm a big fan of the R open source developers as well. Also, you can, if you are available, donate to NumFocus, which is the steering organization for a lot of projects you probably use, including Jupyter. SBO12 says, can you talk about how the availability of features during production impacts selection and transformation of attributes in the model design stage? Yeah, that's a great question. So I think the main thing to consider there is probably leakage. So leakage is where you have a feature that's available during training that tells you the answer. So if you're trying to predict whether or not someone will have cancer, if you know that they've been treated for cancer, that's probably pretty good information to use. So making sure that you are not using features that you won't have access to. Also, if there are features that only exist sometimes, probably not going to be the best to rely on for your model. So examples of features that only exist sometimes. Something like attendance, right? During the school year, when school isn't in session, attendance is not a thing. So if you're trying to use school attendance to predict when you want to, all of the examples I'm coming up with are awful. You're a nonprofit and you want to make sure that you are providing food for after-school programs at the right intervals. You might not want to completely base your model based on school attendance because you might need after-school programs even when there is no school, so parents can be at work or wherever. Just an example. So just some things that I think about. Ash K says, what does the command traindata.cbind test data do? I was a little lost in the docs, albeit a light scanning over. So that takes an additional column called test data and adds it to the training data. And I believe that's with the H2O data frames. Yulia says, how does model evaluation process change when you're doing a Kaggle competition versus putting a model in production? Since in competition, every tiny gain in the metric is important. Yeah, that's a great question. So imagine that we had like 100 more models. You might have, 10 that have really, really high performance on whatever your metric is, but they're enormous ensembles and they take half an hour to run. If that's the case, you might want to not use those models in production because they're going to take a long time to run. So the additional performance gain might not be helpful. Something else that I haven't talked about here that might also be very relevant is how easy your code is going to be to maintain. So if you're in a Kaggle competition and you're using this like cutting edge library that some researcher has like just released, that might be fine for like a couple weeks, but if like the library changes substantially in the future and there's major changes in the way that it works, that's going to be harder to maintain than something that's a little bit more robust and has better backward compatibility. So that's another thing to consider. Yeah. Other questions? Karen says, it seems AutoML does all of the jobs that a data scientist do. I wonder what the role of a data scientist that uses AutoML in their daily job. It does some of the things. It does hyperparameter tuning. Sometimes it'll do feature selection and engineering. Data cleaning, asking good questions, knowing what's a good application of ML, those things are not easy to automate. So even if everything is automated, knowing, hey, we shouldn't be automating that, that's gonna, has the potential to be very harmful, or being able to explain model decisions and design decisions in a way that will help humans get on board with it. And also, just being very mindful of how users will use the model. So more design sort of things, I think, are very much places that it's not easy or even feasible to automate. So that's my things on the matter. I think there will always be room for data scientists. Bobby says, R in Python is just an API wrapper. Yes, I believe. So for Teapot, it's all in Python. XGBoost is a wrapper over a C library. Actually, Teapot might be C under the hood too. AutoML is almost certainly C, and I think there's an R API and a Python API. And then the GCP, the client SDK, is again just something that you're using to interact with it. It's not running the code itself. Actually, it says, is it okay if we ask you more questions about AutoML on Twitter in the coming days when we get some more hands-on experience on it? Yeah, feel free. If you have specific bugs and technical questions, Stack Overflow is also a good place to ask those. A lot of the people who work on supporting the CloudAutoML product are on there. I don't know about H2O. I think probably Stack Overflow for H2O as well. All right. Other questions? Actually, it says data ethics and interpretability is going to be important for data scientists. Yeah, absolutely. I mean, it is important for data scientists. We should be thinking about this. Other questions. In the evaluation tab in GCP, how is calculated the last diagram about feature relevance? That's from Pablo. That's a great question. So what Pablo's talking about is under models. If you look at your model, and then evaluate, I'm going to scroll out a bit so that you can see. So we have sort of things that may or may not be familiar to you, some model evaluation metrics. So we have AUC and F1 and precision and recall and false positive rates, and you can also break that down by class. And the confusion matrix that I mentioned. And then also down here we have feature importance. And it says, there's a little pop-up here, and that is showing on my screen. Excellent. The relative importance of each feature. The scores are normalized to sum to 1. The importance score is determined by how much the prediction varies when the value of the column changes. A higher variance in the prediction indicates greater importance. And I believe that this is across all classes. So looking at the feature importance for our model, the most important feature is current industry. So I'm trying to remember some of the examples of the industries. Like tech or transportation or education or other ones, agriculture. And then numbers of years of experience. And because the job titles don't have things like senior, junior, I'm thinking that this is probably actually a latent variable for how old the role is. So data scientist is a fairly new job title, so it would be surprising to say that you have 20 years of experience as a data scientist, because that's probably not going to be a job title you've had for 20 years. Maybe someone has, but I would be surprised. And then what percentage of your time at work is spent actively coding? So this is not a question that we had in the 2019 survey, so you may have, you'll definitely have different results if you're doing the 2019 data here. The highest level of formal education, so I would imagine especially researchers almost always have a PhD. What is the primary tool you use at work or school to analyze data with? So something else that might be more analyst roles might not be using the same type of workflow. And then none of these activities are an important part of my role at work. So people who are sort of in the other column. Yeah, so that is the answer. Other questions. I'm scrolling up. Mike says, Teapot can use Dask. When would you recommend to use Dask to speed up the training of a model? When it's slow? I have not used Dask, so perhaps someone who has can jump in the comments. All right, continuing to look at other questions. Questions, what's the point of using Google Cloud Platform? So Rudy Haxwell says, you are renting time on a supercomputer rather than working on limited local hardware. Yep, so it's definitely part of it. Again, probably the biggest benefit would be the time savings of putting it into production. So again, if I wanted to create an API to serve this model, I can, oh no, this is not a model. If I wanted to have an API to build this model, serve the model, talking is hard, I could not export. I could do online prediction and create, I'm still looking at the data set, aren't I? Anyway, if I were looking at the model instead, I could launch an API running on GCP that would scale very quickly with sort of minimal effort on my part. So that's probably the biggest benefit of using GCP. And there are also lots of other platforms that will let you do similar things. I think Amazon just launched one. Maybe Azure just launched one. Definitely one of the A clouds just launched one like this week. I said A clouds because they start with A. Data Robot might have one. I think H2O has one. So there's other options, but that's just sort of like why you would use a cloud service over running things locally. All right. Oh, Ryan says, I see the XGBoost issue. You did fit transform on the test data set too. Should just be dot transform after the categories that are learned from train. All right, let's see if I can fix that. Yeah, it would help if I was looking for something that I was spelling correctly. Where are you at? All right, testing and coding. Testing and coding. Fit transform on the test data set 2. Let's see. Going down to XGBoost, XG predictions. Let's take a look at that. And then Y testing. I think it might have just actually done really bad, actually. Because this is, so I'm not using the encoded data here. Yeah, I'll noodle with that. I think something is wrong. I don't know what it is. You did fit transform on the testing data set too. Okay. Testing data set. I believe that you see the problem, Ryan. I just don't while I am staring at a screen and very tired. All right, more questions. Coffee. Yeah, I would love some coffee. I didn't make coffee before I started. I should have. Anyway. Other questions. I see that we can use it as a dashboard like Tableau, isn't that? I think that might be in reference to the AWS one, maybe? JT says, if using stratified samples to specifying a sample weight in AutoML, limit which model classes are tried. Oh, I don't know if it downsamples or upsamples. Yeah, if you can't find that in the documentation, I'd ask on Stack Overflow. It's a good question. Akshay says, second result of your search for fit transform. Second result. Okay, first let's do it one. So the second result, X testing encoded, X encoded, training, testing, okay. But the thing is, I'm not using this X testing encoded to test XGBoost. I think I'm just making the predictions. Oh, let's go down to look the XGBoost one. Sure am. Okay. So, X testing encoded, encoder X, fits transform, X testing. But we do want it to be, I guess what I could do is XGBoost, and then we can look at the accuracy just by Y testing encoded? Surely not. That's not going to work. Yeah, no, it definitely won't. It should just be transform. Fit transform or just transform. I'm refitting the model. Okay. I understand the words you all have been very patiently saying to me in the chat now. I gotcha. I'm picking up what you're putting down. Yeah. All right, so now we should get an error. Could not initialize D matrix from encoder. As I don't want to get too sidetracked, but thank you. On testing X, should it be for transform or just transform? Just transform. Ricardo says, what about class imbalance? Any ideas, moat/rows? I think most AutoML libraries will handle class imbalance for you, but you should check for the specific library you're using. All right, no subverted conversions for type. What does X testing encoding look like? All right. And now, hopefully, this is going to be more reasonable. Yeah. Okay, well, there's definitely something wrong with the, there's definitely something wrong with the encoding. And that can be a problem for another time. I don't want to waste a bunch of y'all's time live streaming my debugging. That's for Fridays. All right, and people are helping me out. You removed transform and left fit. Sure did. Thank you, everyone, for your help. Oh, thank you. Sahil says, you're still pretty awesome in coding, given the time you have in live session. Thank you. I think I would be better at coding if I had a little bit more coffee, probably. Let's go out for more questions. I got this error running code for day 1. I don't think we had code from day 1. I think that might have been from day 2. Leave a comment on the notebook. I'm going to try to be better about being available today. I have so much email. If you emailed me, I'm going to try to get back to you. I'll do my darndest. Everyone's saying they set their code seeds to 42 as well. Yeah, it's just nerd. It's just a nerd thing. It is a good book though. Really Cat says, do any of your models attempt feature engineering per se, such as filling in missing values with imputed values in the event that you do not make them nullable? I believe they all do. I don't know to what what specific feature engineering strategies they're using. Teapot for sure does feature engineering. H2O AutoML, I'm pretty sure does feature engineering, and I'm also pretty sure CloudAutoML does. Pretty sure. Fairly sure. And I did a little bit of cleaning. I actually didn't do a bunch of imputation. I just left columns as they were. I mean, the idea is that hopefully you have to do very little work if you're doing AutoML. And Kate says the BSC license is Berkeley Standard Distribution, is the implementation of Unix developed at the University of California, Berkeley. Thank you, helpful. All right. Kate says, I think imputing missing values is considered part of data cleaning rather than feature engineering. It could be either. Yeah. I think the question is, are you imputing missing values in a way that creates additional usable information, or are you imputing missing values because your model won't run if there's an NA in it? I think would be the difference for me in how I would consider them, but that's just me. And it is time. Kate says, you can always say fixing this is an exercise left to the students. I could. I'll probably spend some time today trying to fix that so it's correct and not wrong. All right. Thank you, everybody. That is the end of the workshop. That's the last day. I will be back tomorrow for live coding. I don't know what I'm going to do yet because I have so much left to do today. But I hope this was helpful for you. I hope it got you thinking about different ways that you can evaluate models, different things that might be important beyond just performance on metrics, and gave you a chance to play around with some different AutoML libraries and see what you like and see what's going to be useful for you in your work. And I will see you all on Kaggle. Thank you for joining me. Bye.